What is the threshold for the amount of DNA that is enough to generate a profile of a potential suspect? Would you stop at nothing? Spare no expense. You can identify all the different sequences of letters A, T, C, and G and match them to a DNA sample that was collected and swabbed from the suspects. And if the two match, you can be relatively confident that the DNA at the crime scene did come from this person. A sample of major crime cases before early 2018 were fully tested unless they returned a value under 0.001 nanograms per microliter. Unless you're a scientist, this number does not really hold any significance to you. Hopefully you can visualize how much 1 gram is. Right, so if you measure a gram of sugar or a gram of salt, it kind of fits into a spoon, and then you divide that by 1,000, that is a milligram. And then you divide that milligram by another 1,000, then that is a microgram. You divide that by 1,000 again, then you get a nanogram. So gram to milligram to microgram to nanogram, and here it's saying it's 0.001 nanograms. So you can divide that nanogram by 1,000 again. So it's literally 1/1 with 12 zeros. That is such a tiny amount of DNA. But where the controversy is, this document put out an option to disregard any DNA sample with between 0.001 nanograms and 0.0088 nanograms per microliter. To be fair, this is a really tiny amount of DNA. Again, it's 1 divided by 1 with 12 zeros, a very, very small, invisible, microscopic amount of DNA. If it's this little DNA, 0.001 nanograms less than that, then they would not bother because it was not an efficient use of resources and they would not go and do that testing. I don't know how you might feel about it. Again, if you were the family member of someone who was assaulted or killed, you would read this number and be infuriated that the forensic testing service did not take this and roll with it and expend all the resources they had to really make sure they could extract all the DNA profiles from this really small amount of DNA. I'm very much on the fence. I hope the technology gets more sophisticated to a point where this tiny amount of DNA, which by the way, if we're working in a research lab, experiments simply wouldn't work. Unless we're dealing with 1 microgram of DNA, it's going to fail before we even start. It's not enough DNA for our experiments. For forensic testing, you don't need as much DNA. The temptation there is for scientists who are limited with resources, limited in time, with a huge backlog of cases, facing taxpayer pressure at all angles. You might say, look, this is such a small amount of DNA that we could put these samples to the too hard basket. As hard as that is to hear for families whose cases are in the pipeline awaiting the testing of these forensic services. How little is too little DNA for anything to be done to generate a usable profile for a potential suspect? If we look at the QIAGEN website, one of these big companies that supply all these DNA extraction kits, how much DNA can we actually put into a DNA gel and still see it? The answer is the least amount of DNA that can be detected with a very common detection agent, ethidium bromide, is 10 nanograms, and it actually recommends 100 nanograms per well to give a sharp, clean band. 10 nanograms is the minimum amount that we can visualize on a gel. The threshold there was 0.001 nanograms, so 10,000 times less DNA than what this website is recommending as the least amount that can be visualized. First sign that that threshold, it might not be great to have, but it's not an unreasonable threshold. If there is not enough DNA to begin with, we can actually try and make copies of this small amount of DNA using a technique called PCR, polymerase chain reaction, where we put PCR primers next to a template DNA. That template DNA would be whatever is found at the crime scene, and try and run a reaction where it makes lots and lots of copies of that DNA. But you still do need enough of that template DNA to begin with to run a successful PCR reaction. So what amount of DNA do you need to run a PCR reaction and to get the ball rolling to make more and more copies? This article is from Thermo Fisher Scientific, which again is a company that makes a lot of these reagents. Their business is in amplifying and extracting DNA. 6 critical components to consider when setting up your PCR, your polymerase chain reaction. What is the minimum amount of template DNA that you need? If you're working with plasmid DNA, which is DNA that's quite simple, it's like a circle, you need, according to this, 0.5 picograms of DNA. A picogram is 1 nanogram divided by 1,000. If you're dealing with very simple circular DNA, plasmid plasmid DNA, then that threshold of 0.001 nanograms is actually enough for you to do a PCR reaction, and then you can amplify the DNA up so that there's more of it, and you can do any subsequent test on the DNA you amplified. But most of the time, the DNA that's found at crime scenes is human DNA that would be pertinent to the investigation. So it's not a simple plasmid DNA. If we're talking about genomic or human DNA, we're talking about gigabases, millions and millions of base pairs. Way more complicated, and in this case, you need 2 nanograms at least to get any kind of amplification. 2 nanograms is 2,000 times higher than the lowest threshold of 0.001 nanograms that forensic testing lab was using as the cutoff to say, hey, it's a too hard basket, it's not going to work. I can sympathize and empathize with both sides of the equation. If you're a family member who has suffered loss, you want no expense spared. You want every possible resource directed towards the scientific testing of the forensic evidence to give you the result to show you who is guilty of this crime. These guidelines that the scientists had put in were coupled with all of these other mitigating factors, that they also had seemingly a toxic work culture, secrecy around the way they did the testing, and there wasn't full transparency. And again, this is where business and science don't truly mix, and hopefully the laboratory testing facilities have other ways of generating revenue so that they are not always under stress, always under pressure to cut, not forced to automate procedures without fully assessing the amount of variability from a manual curation to an automated curation. This all reflects the pressure that the business of science is constantly under, especially in the area of forensics.